All right, let's talk solar. So one of the first things we did when we took over this property was move forward with the installation of solar panels. And I'll tell you that did a year of research, 3 months of design. So I have 13 panels on the front of the house, which is south facing, and then on the eastern side I've got 10 panels up here. Those are 390 watts each, total of 8100 up there. And the strategy was not actually my ideal. My ideal was to have them all on the front, but the installer came with the idea of spreading it out a little bit, which really made sense. So I'm gathering sun right now, midday, and then it swings around, and I'm still gathering it throughout the evening. So it's a really good strategy here, and it's not overloading the system too, which we'll go into detail about that in a minute. Over here on this shop, I have another 5 panels. Those are 390 watt also, and a wind turbine, which is not really doing anything right now, which is really not expected a lot out of that. Let's take a look inside. This is let's take a look at the inverter generator I'm using for this. Eventually our goal is to be, off grid totally for electricity, but to that end I've rewired the panel and moved some of the loads around to where really our daily use, pretty much everything is on sun or solar or battery, with the exception of the dryer, the lights in the kitchen, the stove, which is electric, and that uses like 1800 to 5000 watts. So I'll have another plan for that. But everything we use in our daily use, watching TV, washing clothes, the washer, the furnace, the blowers, all that is actually on solar. So this right here, closet put together, and let's take a look and see what we're actually doing. So this is the Sol-Ark 8K generator, a hybrid. And as you look here, you'll see that right now, on a day like this, we're actually pumping out 6 kilowatts. We're actually sending 4,000 or 4 kilowatts up the grid right now. Only using 410 watts in the house, and the batteries are at 100%. So it's right just now a little bit after 1 o'clock. So my batteries are full, and it'll continue this way for hours right now. Today is projected to be just sunny all day. I've got the critical loads wired into this transfer box right here. So the way the system's designed is that even if I don't have solar, or these batteries, or the batteries I have here can't keep up, it automatically switches back to the grid. But also what it will do is that even if the grid goes down, I really won't know it except for those areas that I don't have it tied to the system, because everything runs off of it. Looking at this batteries right here, 16 of these. These are PCC 230s by Sol-Ark AGMs. I have 16 of them. So this side right here, we have about 44 kilowatts of power just right here in the house. Now, the way I have the system set up is because it's so flexible. And this system is so flexible. It allows a grid tied mode where it sells back to the grid, which you see right there. Meter zero mode, which it actually basically strikes a balance between the grid and the home. So ideal is to have zero electric bill. Smart load capability. There's a there's a function on here that actually allows me to tie a generator or another AC coupled inverter into the system with additional AC or solar. So this will do 8K continuous, and I can actually throw in another, take it up to 13 by just throwing another AC coupled and have a straight throughput. So a lot of flexibility. I'll show you what I've done with this. I actually don't have a generator set up directly connected, have an option for that, but I'll show you what I've done with this. And I left room in here for additional inverter, additional battery. I left space for that as well. So I have some future plans for this area. Let's take a walk out here to the shop. This basement, we're actually in the finishing phases of completion. It's gonna be nice. A nice game room for the kids. Oh, lots of woods out here. Lots of them. And you can hear the wind. And I'm really can't capitalize it on it right now, but I'll get there. I'll get there. It's just gonna take a little time. And there's no rush. I actually don't need the wind turbine, but you know what? If I can gather additional power, I will, because like I said, the goal eventually is that what's going to happen is that wood burner right there, when that finally fails, the plan is not to repair that. The plan is to move on from that and capitalize on additional solar. So I'm not going to wait till it actually fails, but for the next few years, I'll keep improving the system. That wind turbine, that is a Missouri Wind and Solar Raptor, has a span of 70 inches. It's rated at 1.6 kilowatts. So I'm not expecting to really utilize a full 1.6 in this area, but I do know that in late fall, winter, through early spring, winds are about 23 miles an hour. And the way I'm figuring I'm going to do is maybe 15 miles an hour. That'll give me the 800 that I'm expecting out of that right there. But let's continue into the shop here. No more work in progress. Welder. I'm going to teach myself how to weld. Plasma cutter. You know, electrical bench. And out here, what we have is, I was driving it out there. I have two classic 250s at midnight. These are outstanding controllers, but so the one on the left is for solar, and the one on the right is for wind, which is not doing anything right now. They're tied together. Actually, I have them tied together. This is a network switch, so I've actually installed a switch in there so that I can actually monitor it from the house, and actually put a port up there. Solar, this where I have my disconnects. I actually have my disconnects, and I also use a whiz bang. So this one's for solar, this one's for wind. Let's see what else we've got on this system. Battery bank. This is a secondary battery bank. This battery bank right here consists of 24 Crown 235s. The reason for this top like this is that it allows me to get a glance at what's going on as I walk by. You know, that's just to see if I have any batteries that have exploded or anything like that. I don't have to open up the top to see it. I can actually look right through. But the way these batteries are wired, 3 strings, 48 volts a string, gives me a total of 705 amp hours, about 33 kilowatts of power right here. I also installed a self-watering, or actually it's not self-watering, but what I don't have to do, I'll have to open each one. I have a connection. I can actually add this and actually fill the whole system, and then keep an eye on it. Batteries are numbered because I check the voltage. I check the voltage regularly, and so far these batteries have been within 1/10 of a volt of each other consistently. But I'll keep an eye on those right there. I have breakers on this side right here for each string. There's actually several cutoffs. There's a cutoff right there as well. Now, these 3 strings feed into this Ames inverter. This is a 48 volt input, 240 volt output, and this ties back to the hybrid unit on the other side, back over in the house over there. And basically what happens is at night, or like I said, right when it starts to get dark, house switches over the battery, and then when it drops down, which you saw the setting, once it drops down to 80%, this kicks in and actually supplies power and recharges the batteries. So the batteries, as far as depth of discharge, they'll never hit 50%. So that's why I went with the strategy of lead acid. Also is EMP proof. So these batteries right here should last me years. This is a dump load, and actually rectifier. This has, because the wind turbine I'm using is actually AC input. rectifies, switches to 48 volts, and then that feeds directly back into that that classic controller there. I've added a switch. I've added a relay switch so that if the voltage hits 60, it will kick this dump load on, and that will bleed off some of the excess voltage from the battery bank to help save the battery bank. One other feature that I added, the guys that installed this for me did a great job, is that I also have here a input for a generator. So I can literally decide if, for instance, if I have a problem where this battery bank out here didn't receive sufficient voltage, and this would be a period of days, I literally can actually use this. This paper's for the actually for our garden, for our no-till garden, but that right there is a 12,000 peak, 9,000 watt continuous dual fuel generator, and I can at 240 volts. So that right there can tie to this. I fire it up, and that will actually charge the batteries and run the house. I've ran several tests with it, and it's actually just flawless. I like that. And then at the same time, I have more breakers here, so I can actually control what gets what. And in this case right here, haven't had to use that other than once a month now. I fire it up, as you should if you have a generator. I fire it up. Some improvements I'm thinking about making, because the system right now just runs great. Sol-Ark's equipment is flawless. The guys there are great. They've been a lot of help, and I've probably been a pain in the butt because I know I've been testing the system, and I call them pretty much a couple times a week for different things I'm trying to do, just to get more clarification, and they've been just great. The Ames inverter, I can't say I'm really, I like the system. It's robust, but I'm thinking what I want to do is add a AC coupled inverter over on the house side instead, and put things more central there. And that will allow me to have a little bit more control. I think I'll do that next year when I add additional panels. I'm gonna add some ground mount panels to basically supplement the system. And I think that's going to take me over the top as far as when I rewire. I'm going to actually do some additional changes in the control panel in the house and switch those last final rooms over to solar. But overall, that's a overview of the system. As we continue to make changes, I'll give you updates, good or bad. But right now it's actually functioning flawlessly. Right now, the solar panels are still kicking in. I've gotten 1.8 kilowatts today, and battery bank is pretty much full, or it's about to be full. The way it's set up though, this wind turbine won't kick in until until it hits, in this case, 60 volts, and that's because the batteries are already full. They actually work together. And again, that's our solar system, solar and wind. If you have any suggestions or comments, please submit them. For me, it's just still learning, but I'm really happy with the way the system's been performing. A day like today, I could actually literally have another battery bank, and it would fill it up on a day like this. And the goal is we don't get credits or cash back in our area. We do get credits. So the overall plan is that in spring and summer, when it's like this every day, is to just build up credits, and then through the winter months we can actually use those credits and not have an electric bill, which we don't have an electric bill now. That's the funny thing is our last electric bill was $243, and then installed the solar, and I was kind of messing around with it and tweaking it, and then our first bill for a partial month was $73, and then the next projection said it was going to be $161 lower than 73, which I actually thought was just funny. So right now, it's a great sunny day out here, windy. I wish I can really capitalize on the wind as well, but that'll be something I'll address next year. But if you have any questions, I'll put a detailed list, a parts list of what the system comprises of, but I'm really really enjoying what how it's performing right now. And the company that installed it, their guys, they did a great job on it. Oh, one other note too, that and I don't know if anybody who's had solar before had to deal with this, but if you look around the base of the panels there, you'll see guarding, a squirrel cage. And what that does is it protects the system from rodents, raccoons, things like that can get under there and actually start messing with the wiring. So that's it's well worth that right there. These panels are actually wired in series. Those are wired in series, and those are 2 strings wired in series as well. But I see that the system works really well. Comments, like I said, any suggestions, please upload them, and I'll try to answer as many questions as I possibly can. Thank you, and see you in the next one.